So last time we have defined the module tree. Module tree is a finite rooted tree with labeling, so that if we have a vertex in this rooted tree and its children, its child, then their label must be related. And if alpha and beta are related and u and v have corresponding labels as alpha and v, then they are at different depths. And we define this because we want to analyze this log. And this log comes from this log module species algorithm, which is what we want to study. So now our goal is to show that this module species algorithm, with high probability, it ends in a relatively short time. Recall that this fixed algorithm is that when we have these many elements in some finite set omega, and each of them is an independent random variable. So you can consider this as like coming as a red or blue. And these bad sets, bad events, are depending on finite number of these independent random variable. And what you do is we take a random, we choose all the, this CV, which is independent random variable, at random. And then if some bad event happen, then we select one and we resample this independent random variable. And if we see another bad event, then we again resample them. And this resampling might introduce new bad event, but in the end we want to show that in finite time with high probability it will end. And the log was defined to be the sequence where each elements are the bad events that we resampled. And then our goal is to make a correspondence between this log and module tree to found the probability of getting specific sequence as log. So now we define how we can correspond the module tree to this log. Let's say alpha 1 to alpha u be a prefix of log. And we will associate to it a labeled rooted tree, TU, in the following way. How do we consider it that the root has label alpha t, alpha u, and we see the sequence from backward. So from here you start and then you consider, and let t run from u minus 1 down to 1. If we do not have any alpha, any t prime, which is related to alpha t, or already added one. let's just say, let's identify, no, it might be more confusing, so let's write it this way. Has been already placed in TU, then we ignore alpha t. Otherwise, meaning that if we have already t prime in here, in this module tree, in this rooted tree we have so far, we choose select one such that the vertex labeled alpha t prime is at the largest depth. And we can, if there are more than one choice, then we break ties in an arbitrary way. And we add a vertex with label alpha t and make it the child of the vertex labeled alpha t prime at the greatest depth. Meaning that if you have alpha t plus 1, alpha t plus 2, alpha u, and you have a vertex with label alpha u and some others. Let's say you have alpha t plus 2